Hello the internet and welcome back to my channel. Today on the bench we have a soldering station. It's a Bakon BK601 Pro. It's a 245 tips based station. I've recently reviewed another Bakon station. The review is here if you want to take a look. The review went pretty well, so I'm actually curious to see what Bakon has to offer with this one. So in this video we're gonna test this station, make sure that it's properly grounded, that there is no voltage at the tip, no voltage leak, no current leak, that it works totally fine, it doesn't overshoot, and in the end I'll come up with a conclusion and I'll share that with you. I got this station from Bakon for free. However, I was clear with Bakon that the outcome of this review is going to be my honest and unbiased opinion. So enough me talking, let's open this box and see what's inside. There's not much in the box, it's just the station. There is a 245 handle and a mains lead, which, as I was expecting, I was made aware of this, is not available in with a UK plug. But at least the station comes with an IC plug at the back, so you just need to get your own IC mains leads, which you can find them basically everywhere. We call them kettle leads here in the UK. This station, compared to the other one, comes with an integrated stand, so everything is in here. I'm not a massive fan of this. It comes with advantages and disadvantages. The disadvantage is that you need to have this station on your desk. It has a much bigger footprint, but it's not the end of the world. I mean, my JBC is exactly the same. One thing that catches my attention immediately is that this station is very, very light. I'm aware that the station is featuring a switch-in mode power supply and not a linear transformer. And I have to say I'm a bit skeptical about this, because every single station or soldering iron that I've been using with a switch-in mode power supply inside, they always have all sort of voltage at the tip or voltage leak or current leak. Now, Bakon was adamant that I was not going to find any of these on the station, so I'm really curious to see the outcome of my tests. I would say let's turn it on and see how it works. Let's take a look at the menu, which is very, very basic. And while I don't mind basic menus on a soldering station, I don't need a color display, I don't need AI. This is really, really basic. The main display will show the current temperature, 350, the set temperature, which can be changed very easily with the arrows, and the number of seconds which are left for the iron to go into standby. And here on the right hand side, the current power sent to the heating element. To get into the menu, it's the start button, and the menu is very, very simple. You only have 4 items, 1, 2, 3, 4, and 0 for saving. Now the menu will go back to the main screen after a few seconds, so I'll keep cycling a bit. Menu number 1 is the wake up temperature. It's set to 350. I don't really think there is a need for a wake up temperature. I'm happy with the last used temperature, but anyways, it doesn't hurt. Menu number 2 is the offset. So if I'm pushing the start button again, I have 0 degrees, I can go plus or minus. Number 3 is whether you are using Fahrenheit or Celsius. And number 4 is the sleep time. I set it to 99 seconds. More than that, it can only be disabled. And I really would like more than 99 seconds. I think on my JBC I have like 15 minutes because I don't really like the tip to go up and down in temperature too often. Once any of these settings have been changed, you need to go on menu 0 and tap the start button. It will say succeeded, and that's when all the settings have been saved. If you don't go through that step, well, the settings are lost. Again, very simple, maybe a bit too simple, let's put it that way, but hey, it works. In the end, it's a soldering iron, it's just a stick that gets hot and it melts solder. So I would say this is enough for a soldering station. Now, a couple of things I'd like to mention straight away. Number 1, the iron is making this weird chirping noise. Even when it's idle. It's definitely doing it when the heating element is being energized. Let me see if I can put it on the microphone. This is audible, unfortunately. It's not nice to have this thing chirping on your desk. The other thing is that some metal parts, like these edges here, they're pretty sharp. I mean, someone can definitely get injured or cut on these edges. Let me show you what I mean. This is really not acceptable. It's in a reachable place. It's not like I'm going under the station or anything. I guess it can happen that you're grabbing the station from here. It's not super sharp, but it's sharp enough to cut a piece of paper, and once again, I don't find that acceptable. And the final point is that I found this bit not completely attached. I'm not entirely sure. I don't see, oh, there's some, it's attached with double side tape. I can feel it's sticky at the bottom. So I guess I just need to push it down. Again, maybe not the best quality control. Is this part sharp? No, it's not, which is great. Probably that's something that you'd notice straight away. And that's it. I would say let's move to my basic tests. Checked for ground and leakage of any sort. I got my multimeter connected to ground through this black lead, and we can confirm that on the mains cable. It's reading 1 ohm simply because these leads are not great and they show 1 ohm if I short them together. So it is connected to ground. Now let's plug the station here. And the first thing I've noticed is that if I touch the chassis, the metal parts of the station, it's not reading 1 ohm, it's reading almost 3. So there are 2 ohms somehow being added by the station, because the cable itself is reading 1. Now you notice the station is in standby mode, and you'll understand that straight away. So let's disable the standby for a moment. Now let's see what happens if I'm checking the grounding of the station while the heating element is being energized. Well, the fluke is not happy. Yeah, that usually happens when there is some voltage. Now, let's check the tip itself. Yeah, I have the same result. So, are we getting some voltage here? That wouldn't be great, as I said at the beginning of the video. Now, in DC mode, I do see something, but it's not like a definite number. I'm assuming that these stations with the switching mode power supplies, they're driving the tip in a PWM fashion. So I'm expecting very fast pulses to be sent to the tip, and the multimeter is not fast enough to record that. Let's see what we have in AC mode. And it's the same thing, but there's definitely something going on there. And as I said at the beginning, I don't like it. There is one simple test that will tell me whether we are getting some leakage, whether it's voltage or current out of the station. And it's by using this little speaker, which is connected to ground on one end. So let's wet the sponge. And let's see what we're getting. Well, clearly there is something coming out of the tip. If you have sound out of the speaker, clearly there is electricity flowing through the speaker. This is a matter of physics. So this is already a big no-no to me, but let's investigate this further. Let's try and find out what we're getting out of this tip. I think we will need our oscilloscope, but before doing that, let's try the multimeter in current mode. I'm in AC current mode, and yeah, well, I do see something. Obviously, the tip is only being energized very rarely just to keep it the temperature. So let's try to trigger more power into the tip to try and get a more accurate reading. Where I'm reading 0.33 amps in AC mode. Let's see what we're reading in DC mode. Yeah, something like that. Now let me try and turn off the station. I'll let the tip to cool down a bit, and then we'll try and measure again in AC mode while the tip is being brought to 350 degrees. That would be many seconds of full power, and we might be getting a more accurate figure. And then we'll check with the oscilloscope. So we're reading 0.6 amps in AC while the tip is being energized. This is completely unacceptable, unfortunately. I cannot accept a soldering iron which has 0.6 amps AC leakage from the tip. But let's try and visualize those spikes using the oscilloscope. Now this is what my oscilloscope is seeing, and I think we see two different pulses here. Let me see if I can pause it to show you. We have these, I would say, high frequencies pulses, which, if you consider the resolution of the oscilloscope right now, 5 volts per division, they go up to 20 volts, even probably more than that. And I feel that that is a lot, but that is not what is driving the heating element, I feel. It could also be noise being captured by the probe itself, I don't really know. But I think what's driving the oscilloscope is this. I think these are the actual pulses driving the heating element. We are talking about 0.96 volts peak to peak, and if I'm measuring that right, these are happening at 1.8 kilohertz frequency, which I feel is the frequency that we are hearing out of the soldering iron. This is a 1.8 kilohertz I've generated with Audacity. It's a square wave and it sounds like this. And I think that's what I'm hearing out of the soldering station. So unfortunately, this is completely unacceptable. The station is, yes, it's grounded, but it's got voltage and current leak out of it. And again, my multimeter is only reading 1.6 amps in AC. I don't care, it must be 0. And the same with the voltage, I don't want to see voltage out of the stain, whether it's 0.6, 0.9, 20 volts, it has to be 0. Does that mean that this station is going to ruin your components? Well, maybe, there is a chance. I had a similar issue with the Aixun T3A, I published the review some time ago. So the point is that the moment you have current flowing from the tip, well, it's going somewhere. And most of the components, especially big, large, discrete components, they won't care about 0.96 volts, but some components, they might not like it. And I don't want to take a chance. It's a soldering station, it needs to have 0 volts at the tip and 0 amps at the tip. Full stop. Now let's move on with the review. Let's do my favorite test, the coin test, and let's compare it with my JBC, genuine JBC station. For this test, I'm going to melt solder on a small coin and then on a larger square of copper. This doesn't represent the average soldering, but it will highlight the power capabilities of the stations. The very same tip is being used between the tests, and the tip temperature was matched before the test. In the background, you will hear the chirping noise produced by the Bakon station. Let's quickly check the temperature accuracy out of the box. This is the tip I found inside the box. Let's see what it reads. Well, I'm reading about 300 degrees. That's wildly inaccurate, I would say. This is my genuine JBC. Not that the JBC is magic here, but I don't really trust this thermometer. So let's see what it reads out of the JBC with a JBC tip, set for 350. Well, I'm reading 320. I know that my JBC station can read up to 20 degrees off, but this is reading 50 degrees off. It's a bit, I mean, it could be the tip. I've tested with many tips, and I kind of gave up with the offset because each tip has a different, would require a different offset, but I've never found anything which was 50 degrees off. Anyways, let's try and compensate it through the menu. That's menu 2, and let's try and set, I don't know, let's begin with maybe 40 degrees. And then I'm going to 0 and save. And let's see what it reads now. Let's give it a few seconds. Well, I'm reading 320. Fair enough, it's a small tip. Let me try with a slightly bigger tip. Now I've disabled the offset, and I'm actually using the biggest JBC tip I've had. Let's give it a few seconds to stabilize, and then we'll check again what it reads with this one. That's a bit better. I'm reading 330, which is, again, is not perfect, but honestly, when it comes to soldering irons, I'm not really expecting that massive accuracy. Now, let's try and compensate it now, 20 degrees. That's it, now I'm reading 350. So yeah, I mean, the system is working. Obviously, probably my thermometer has some issues reading from this tip because it's very, very small. The tip is very small. With a bigger tip, it looks to be fine, to be honest. I'm not too concerned about that. It's time to take a look inside. Let's open it up and let's see how it's made. Factory seal. There are little voltages inside these machines, so if you don't feel comfortable working with mains, please don't do that, and this is not a tutorial. And the station is open, there's not much inside as I was expecting. We have the switch and mode power supply, we've got mains coming here, and then we have DC coming out of here, which is going inside where, that came off. That's very, that's very convenient. And that is the microcontroller board. I already see that the microcontroller name has been erased on this one, unfortunately, but everything is wired with connectors, which is a little nice touch, so we can disassemble a bit further. This is a USB port. I think I never mentioned that there is a USB port at the front for charging. This is just power, so I'm assuming this is getting 5 volts from the power supply board, and this is the output going to the handle. Now I don't see anything nasty, everything seems to be done nicely, the power supply looks to be okay. We'll remove it from the chassis and we'll take a closer look in a second. Now before I do that, a couple of things I'd like to show you. Number one, everything has been heat shrinked for better insulation, but there is one wire which unfortunately is showing the copper. And it's this wire here. Unfortunately, the heat shrink was a bit on the short side, and we have the copper of the wire exposed. That is 240 volts mains, that's the live conductor, so that's not great. Now, before I disassemble any further, I'm curious to take some measurements. I want to see what kind of voltage, DC voltage, we are getting to the electronics, and which in turn should be the one going to the handle. I'm going to use my current limiter and isolation transformer. There's no handle connected, so that should be totally fine. It's interesting, we're getting minus 20 volts, but the polarity is correct. At least I got the black on the black and the red on the red, and we're reading a negative voltage. Anyways, 20 volts DC is what we are getting for powering both the electronics and I guess the handle. I can't be 100% sure, but I guess the 20 volts is being switched to power the heating element inside the soldering tip. And of course we have 5.1 volts for the USB socket. Power supply is out. I think I like it. There is quite a lot of separation here. This is where mains is coming. So this is the primary section, that is the secondary section. And we only have an optocoupler in between the primary and secondary. And I think behind here there is a Y safety capacitor, the blue one here. This is the MOSFET for the switching, and on the other side we have a diode for rectification. We have some capacitors. These are like Chinese brands, of course. This is a Yunrui, but it's 105 degrees, and these are Cheng's capacitor, and these are also 105 degrees. I can't really find the controller on this power supply, so I'm assuming it's this little IC here. It's barely visible. I wasn't able to identify it using the marking on the case, but it looks like it's the only thing that can be a controller for the switching. It's also getting signal from the optocoupler, so I guess that's it. This is the output where we got the 20 volts going to the electronics, and this is a 5 volts regulator. It's a buck converter, DC to DC, which is sending 5 volts to the USB port here. I don't see anything nasty. There is a big separation between primary and secondary. There isn't separation here as cutouts on the PCB, but there is quite a distance between the primary and the secondary, which happens to be the USB port. I don't know how much you can see that, but I see cutouts on the PCB in between the legs of the MOSFET. So yeah, it looks like it's nicely done. I don't see any safety concern. That being said, again, I'm not an expert, so take everything I'm saying with a pinch of salt. Here is the controller board. Unfortunately, the MCU has been erased, so we don't know what that is. I see that this is labeled 602S Pro motherboard version 4. This is a 601, so I guess this is being reused between different models. Also, I see an AC input here. So that also suggests that this is being reused between different models. There is a connector here for some fans. There is a connector here for a switch to select 110 to 120 volts on the controller board. I'm not sure how that works. But anyways, this is the 20 volts input. It says DC 20 volts, and we actually measure that. And this is the output to the handle. And this is the P-channel MOSFET to drive the heating element inside the handle. There's not much happening on the other side of the board. I see some passive components, probably some diodes. And then obviously we have a ribbon cable here, flat cable, going to the front PCB, which is just a big display with some switches. And this little ground cable is not a ground cable, but it's basically the cable going to sense whether the handle is in its stand for the standby operations. I've now tested the Bakon on a grounded PCB. If you watch my review of the Aixun T3A, I discovered that that station was massively misbehaving when ground was in the way. I did exactly the same test. I grounded this board, the same board by the way, by the heatsink. Ignore that this is a red cable, but this is ground, and I started soldering around, looking for something weird. With the T3A I had overshooting up to 100 degrees, but I'm happy to say that the 601 Pro did not show any issues whatsoever. I was soldering on the board and then checking real quick the temperature on my tip thermometer here. I never saw anything weird. Also, because the station is making this chirpy noise when the heating element is being energized, I had this kind of audible feedback that nothing horrible was happening while I was soldering on this grounded PCB. Now, I know that some of you might think, why would you ever solder on a grounded PCB? Well, there are a number of reasons why that might happen, and one very real-world situation, which is how I discovered the issue with the T3A, is a preheater. Your board is sitting on a preheater and you're just soldering on it. The preheater has to be grounded by law for safety reasons, and automatically your board is being grounded because it's touching the preheater. Yes, you could try and insulate it, you can try and put some tape around it, but that's not the point. A good soldering station should not misbehave when ground is around. So happy to say that the 601 Pro doesn't seem to have this problem. However, I noticed that when soldering on a grounded surface, the very same chirpy noise is coming from the tip of the iron. This is touching a non-grounded surface, and this is the same surface but connected to ground. As I said, that leaked current has to go somewhere, and it's not nice to know it's going through the PCB I'm working on. Now, the stand of the 601 Pro is definitely better than the stand of the other Bakon station that I've reviewed on this channel, but I still have some reserves, let's put it that way. And it's once again the removal of the tips. Now, there are these little holes on the stand, and I'm assuming that this is designed to remove the tips, fair enough, but now the tip is like in the way. I can't plug it back in if I want, so I'll have to grab it with my hand, which is not a big deal. This part of the tip is never scorching hot, and put it somewhere else. So definitely better than the 999 stand, but I don't understand what's wrong with the JBC way of doing it. It's a simple design, it allows you to remove tips and swap them real quick, and I don't understand why this needs to be reinvented. To be honest. So, yes, fair enough, it's better than the 999 stand, but it could have been as simple as the one used by the JBC, and in my mind, it would have been much better. So, do I recommend the soldering station in the end? Well, when Bakon got in touch with me at the very beginning, I did tell them that I wouldn't be able to recommend any soldering station to my audience if I was able to measure more than 2 millivolts at the tip as voltage leak and any amount of current leakage from the tip itself. And Bakon came back to me saying I wouldn't be disappointed, but unfortunately I do see a voltage at the tip much more than 2 millivolts, and most importantly I see current leakage. So no, unfortunately I cannot recommend the soldering station. Now, if you're thinking 2 millivolts is unreasonable, well, that's what Bakon themselves say on their own manual, not of this station, but of the other one, the 999, which is based on a linear transformer. It says tip to ground potential less than 2 millivolts, and I think this is exactly what my JBC station says. I feel it's a kind of a industry standard just to say there's no voltage at the tip. Now, the thing is, this station is probably going to be safe 99% of the time. Probably the voltage, the current leakage from this station is not enough to cause damage most of the time, 99% of the times. It's that 1% that bothers me. I don't want to use a soldering station thinking that there is a remote possibility that it might damage some components of my PCB. And particularly because there are alternatives. You can buy a good soldering station with 0 voltage at the tip and 0 current leakage. And one example is the Bakon 999. It comes from the same manufacturer. It just happens to have a linear transformer inside. So no, unfortunately, I cannot recommend the station. I'm sorry, Bakon, that's probably not what you wanted to hear from this review, but I did say at the beginning that this was going to be a honest review. I did inform Bakon about my findings, and unfortunately they confirmed that this is the expected behavior of the station. So no, I cannot recommend the station. So what can I say? Let me thank Bakon for sending the station for review. I hope you enjoyed the video, and if you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and Patreon, the links are down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to support me on Patreon, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, well, I hope you enjoyed the video. That's it for today, thank you for watching, I hope you have a great day, and hope to see you soon here on my channels for my next videos. Thank you very much, and goodbye. Bye-bye.